welcome back for Module 5, Lesson 3, Estimate Irrational Numbers. It's homecoming week at my school and we're doing Hawaiian Day today, so I've got my Hawaiian shirt on. It's going to be interesting to see how my green leaves work with the green screen background. The goal says students will estimate irrational numbers. Suggested pacing guide says this is going to be a 2-day lesson. Let's get into it. There's 17 resources we need to get through today. The formula t is equal to the square root of h divided by 4 can be used to find the time t in seconds it will take an object to fall from a certain height h in feet. Suppose an apple is 13 feet above the ground. If h is equal to 13, then the expression square root of 13 divided by 4 can be used to determine the amount of time it takes for that apple to hit the ground. I'm curious, it's in seconds, there it says, so yeah, so that would be, well, I guess if you really want to know how long it's going to take for that apple to hit the ground, then that's a good formula to know. How could you use an irrational number such as the square root of 13? Well, that's some of the things I guess we're going to be learning about in this lesson. Now, I totally skipped over the explore part of this lesson because it's expecting you to know things about the Pythagorean theorem, and we've not even touched the Pythagorean theorem yet. I doubt you touched it in 6th grade either, so it's kind of pointless to try and do a problem involving it that you've never learned about it. Let's move on to the first learn this part. It says the decimal expansion of an irrational number never repeats and it never terminates. It's a non-repeating, non-terminating decimal. To write the decimal expansion of an irrational number, you can denote the approximation by using the about symbol. So that about symbol right there, that sucker is going to be pretty important. We're going to be using that throughout this lesson. Use more place values to give a more accurate approximation, and now we're going to watch an animation to see how to estimate the square root of 8 on a number line.
Graph the square root of 8 on the number line. 8 is not a perfect square, so you must approximate the value of the square root of 8. Since 8 is between the two perfect squares 4 and 9, the square root of 8 will be between the square root of 4 and the square root of 9. The square root of 4 is 2, and the square root of 9 is 3. So the square root of 8 is somewhere between 2 and 3 on the number line. Since 8 is closer to 9 than 4, graph the square root of 8 closer to the square root of 9.
Well, that looked pretty simple. This is going to be where we're moving them to the nearest whole number. You're later going to learn how to move them to the nearest tenth, but so far, that's a pretty simple problem. So let's look at example 1 that says estimate the square root of 83 to the nearest integer. Now, in doing this one, I want you to stop and consider some things. 83 is between what two perfect squares? That's the goal. We got to figure out which perfect squares it's closest to, and hint, it's going to be 81 and 100 right here. So we're going to find the two perfect squares between which 83 lies, and the greatest perfect square less than 83, that's going to end up being 81, and the square root of 81, that's going to be 9, and the least perfect square that is greater than 83, well, that's going to be 100, and the square root of 100, that's going to end up being 10. So we know that the square root of 83 is going to lie between 9 and 10. Next question, is 83 closer to 81 or closer to 100? Well, 83 is definitely going to be closer to 81, and since 83 is going to be closer to 81, that means our answer has to be closer than 81 too. So it tells us right here, plot the square root of 81, 83, and 100, and then approximate the location of 83. So let's see here. I'm going to start off with, let's do a green one for the square root of 81. That's going to be 9. Let's use an orange one for the square root of 100. That's going to be 10. And I'm going to say that the square root of 83, that's going to be really stinking close to 9. So I'm going to put it right about there. And from there, let's take and compare our answers, check the answers, and they put theirs there, show my answer, and well, let's make it smaller so we can see them together. So show their answer. I was a little bit off. I was close, but I was a little bit off. So still not too bad. Now that showed us estimating on the number line. We can also estimate it with math, right, in an inequality. And this right here, folks, this is what you're actually going to be doing on your paper. You took the 83 and we put it in between the two closest perfect squares. From there, we're going to say the 81 is going to be 9 squared and 100 is going to be 10 squared. That means the square root of 9 squared is going to be 9. The square root of 10 squared is going to be 10. Honestly, guys, I just put a square root over the 81 and the 100 there and get a 9 and 10. I'd kind of skip this middle mess right here. And that means that the square root of 83 has to lie between 9 and 10. From there, you have to figure out which one's it closest to. It's closest to the 9, so we're going to estimate the square root of 83 to be about 9. It's really that simple. That's all there is to doing these when you're estimating to the nearest whole number. Alright folks, now it's your turn. Pause the video, work this one out on paper on your own. Go. So this is how I would show my work. I'd start off with the fact that we're looking for the square root of, was it 53 I think? Let me go back and look over here. Nope, 54. The square root of 54. And I know that the square root of 54 is going to be between two perfect squares, which is going to be 49, the square root of the square of 7, and 64, the square of 8. So I got to take the square root of both of those. The square root of 49 is 7, which is less than the square root of 54, which is less than the square root of 64, which is 8. That tells me that my square root of 54 is going to lie between 7 and 8. Next, I'm going to say, what's it closer to? Well, 54 is 5 units away from 49, but it's 10 units away from 64. That means my answer is going to be about 7. Jump back over here, type in the 7, check our answer. It really is that simple. And by the way, that constitutes showing your work. That's all I've got to see on your homework tonight. Now we're going to step our game up a little bit. We're going to estimate the square root of 83 to the nearest 10th. That's going to require a fair bit more work on our part. So let's get into this. I'm eating some cookie dough, by the way. Cookie dough is always good. First thing we want to do is to determine the integer that's closest to it. As you remember, we've already done that before. We were looking at the square root of 81, which was 9, and the square root of 100, which was 10. Those check just fine. From there, we're going to take and say that we know that the 81, or the square root of 83, is going to be closer to the 9. And after finding it closer to the 9, well, then it's time for things to get downright painful. We're going to take right here and pick 9.1. Why 9.1? Because it's the closest number to the 9 that's bigger than the 9. The closest 10th to the number to the 9 that's closest to the 9. So when you take and square 9, you got 81. When you square 9.1, yes, you can use a calculator for this. But don't use your calculator to find the answer. Don't do that. When you square 9.1, that would end up giving you the 82.8. So with that in mind, 83 is going to be closer to 81, or is 83 going to be closer to 82.8? First off, the inequality is true still. The square root of 83 is going to fall in between them. Actually, hold on. Is it? It's not. It's not true because 83 is greater than 82.18. So right there, the inequality is not true because 83 is not between 81 and 82.8. So since that didn't work, we now can take and say, well, we know 83 is larger than that. So we're going to go from there and we'll say, well, now we need to put it between 9.1 and 9.2. They did that again, and they said, well, now when we square 9.1, we get 82.18. When we square 9.2, we get 84.64. Does 83 lie between these two numbers? Yes, it does. So that is a true statement because it is between the two of them, and we're going to check that. Now, we know that to the nearest tenth, it's either going to be 9.1 or it's going to be 9.2. Because the answer lies between them, now we have to figure out which one's closest. If you look down at the bottom of the page right here, you can see that 83 is actually going to be closer to 82.1 than it is 84.64. Think about this for a minute. 83 is 0.19 away from this one. However, it is 1.64 away from that one, and because of that, we're going to estimate it to be approximately 9.1. 9.1 will be the square root of 83 rounded to the nearest tenth. Now it's going to be your turn. Pause the video and see what you can come up with for an answer. Go. So I set up my original problem with two inequalities showing that the square root of 46 is going to be greater than the square root of 36, which is a perfect square, and less than the square root of 49, which is a perfect square. When I take the square roots of my two sides, I'm going to acknowledge that the square root of 36 is going to be 6, the square root of 49 is going to be 7, so the square root of 46 lies somewhere between those two numbers. Now we need to figure out how close it is. Well, it's going to be fairly close to the 7, because if you think about it, 36 to 46, that's a difference of 10. 46 to 49, that's a difference of 3, so it's going to be closer to the 7. So now we're going to have to break it down from there and pick some points between 7 to work with. I don't think it's going to be down really low. I don't think it's going to be right there by the 7, so instead I'm going to go ahead and start off with my 7.1 and my 7.2. So I got my inequalities here just like the textbook did. I'm going to square each of those. Which I'm going to square each of those just like they did, and that's going to give me 46 right there. So 7.1 squared, grab my handy dandy calculator, 7.1, and by the way, this little thing right here is a square button. That's going to give me 50.41. So that I will have 50.41, and then 7.2. Oops, wait a minute. I just realized I did something bad. Let me show you what I did wrong. That took me to, I did that one wrong too. 7.2 squared. That one gave me 51.84. And notice both of those numbers are greater than the square root of 46. So that is not going to work at all. And I realize what my issue is. I'm going to be closer to 7, but it's still going to be a number less than 7. Therefore, I'm going to take all of this stuff right here, and boop, I'm going to delete it. And now I'm going to try this. I'm going to try putting it between 6.8 and 6.9. So we need to do our number again, and we're going to take and square these two values. 6.8 squared, hit my square there, that's going to become 46.24. At that point I can actually stop, because is 46.24 less than 46? It's not, so I have a false statement. That means I need to take and do it all again. So I'm going to highlight that. I'm going to try one more time with a number less than the 6.8. So now, instead of being between 6.8 and 6.9, I'm going to try putting it between 6.7. If I can get my thing to work here. There, it's starting to work. So I'm going to try and put it between 6.7 and 6.8. And we're going to check that and see if that becomes a true statement. So from there, I'm going to grab my calculator. And my calculator is right here. 6.7. We're going to square it. And that's going to give me, oh, I think I hit the wrong button. Let me clear this out. Make sure 6.7 squared. That's going to give me 44.89. That is a true statement. 44.89 is less than 46. So right there, of course, we need to have our squared buttons here. So, and we need to have the radicals there too. So from there, we could take and say that part is going to be true, and then we're going to take the 6.8, 6.8, and then we're going to square that, and that's going to give me 46.24, and 46.24, well, that is going to be a true statement too. It is greater than 46. Finally, what number is it going to be closest to? It's going to be closest to the 46.24. That means the square root of 46 is going to be about 6.8 for your final answer. That's an awful lot of work to find these answers, and quite frankly, it's why I don't like doing these. It's something that's important to do in order to understand the concept, but in the real world, you're going to use a calculator for finding square roots. Do it like this for your homework, be ready to do it like this for your test, but don't expect to have to do this every day in the real world. That is going to be it for part 1. When you come back to part 2, we're going to do example 3, where we learn to estimate cube roots to the nearest integer. I'll see you in that video.